Hi everybody, it's time for a teardown video. This thing here, I don't know what it is, found it at the hospital's scrap bin for electronic stuff, but I think it's used for the respirators. And this is just the alarm part of it. So if something, if it here stands high breath rate and low minute volume alarms here, and the breath rate here and the volume and stuff. There's alarms on top and some briefing data. So I took this because I want to take my little angle saw, so a hole in here. I put my power meter in it. 1 kilowatt-hour meter. That's why I got it. Don't have a really not so huge use for that. To have a briefing computer. So yes, there was a little tube going in there, but I took that away when I got it. Here it is. Here's some kind of tube, and we got some regulators and stuff. That goes to a hose. Let me show you the hose. And yes, there's the hose. One of the tubes is for oxygen, pure oxygen, and the other one is for the normal air. That means 21% oxygen and 70% nitrogen. And as in this one, that goes in that monitor, goes the oxygen tube, like so, and measures that. There's a little cone in here, so when the air passes through, it will create a little vacuum in this. And that will go and registrate it. Let's see how that works. And yes, and that monitors that oxygen flow in that way. So let's take it apart. I've already taken the screws off. Some stuff on the back here. We have a voltage selector. There's a little apnea button here. I don't know what that does. Data in, data out. Optic fiber, of course. Switch. Gonna salvage those. Handy to have for high voltage experiments. And there's not so much stuff on the front. And it's the another one tube will go in here, but I don't have that. Let's take it apart. We are in like Flynn. Nice metal case. Pretty good quality stuff. Need to be good quality when it's hospital stuff, and especially for respirators. So yes, let's have a look what we got in here. And a quick shot from bottom part. There's the IAC standard 69324. Let's have a look what we got inside here. There's some valves here. Some kind of oxygen sensor, I think. Is that oxygen sensor or flow sensor? I don't know. We'll see that when we take it apart. There's a pressure sensor here. Some optic fibers. There's a link. And those goes to the circuit board. Got the power supply here. And we got the controller, I think. Yes, the controller is on the front. This part here. And the display is on the back, so 2 boards here. And yes, let's take it apart. Let's see if we get any salvageable parts in here, so that we can have some use for. Yes, most of the screws are Torx. There were some insect screws on the back, or hex screws, but the rest of it is Torx. So let's see if I can get this thing apart. I don't have the right drivers for it, it's a bit too small. I'll try to crack it open somehow. And always I keep those screws from medical equipment, they're pretty high quality. They are stainless. Don't go to the magnet. Here we go. And now this should just pop off. Here we go. Let's have a closer look on that circuit board. It's a heavy transformer on it. Let's input here. 2 inputs. Is that the input? Yes it is. Because we have that voltage selector. 2 inputs goes into this main stator transformer. It stands signal transformer on it, but it's not. And the output goes from here to the full bridge rectifier, and after that it goes to 12 volt regulator. It's a 12 volt regulator here. There's a 5 volt regulator on the back. This is fused. There's a fuse on there. I'll show you that later. That's the main voltage reference, MC1403U. That's the full voltage reference. Goes to LM339AN, that's op amp. Those two work together. And if I move that a bit on that side, you can see that here we got the 555 timer oscillator. I don't know why they use oscillator in here. There's another op amp here, the same as this one here, LM339AN. Lots of passive components around. We move it on this side. You can see the fuse with a little connector here. And that's a big filter cap. Mallory. I've never heard of Mallory capacitors before. 35 volts. Maximal surge 44 volts. Don't know where it's made. Capacitance 5600 microfarads. So that's a neat little power supply. And on the back, copyright 1990. Bird Products. It doesn't stand where it's made, but I think it's made in the United States of America. So yes, let's dig further in this. That's nice. I labeled every single wire here. So labels on almost all of them. Here got another one. Here's another one on this. And no, not so much on the tubes. Yes, and here we got everything spread out on the table. The power supply here, main processing unit here. Got a display unit, those valves for the airflow, pressure switch, and yes, not so much in it. But very nice stuff. Here's all the valves here, and there's a precision valve, I think. That's not a sensor or anything, that's just a normal, that's a very high quality air switch or a pressure switch. Maybe it's that measures the breathe rate. There's some kind of overpressure switch. There's a little micro switch in that. And here we've got the main processing board, the memory chip. That's the memory chip, and there's the processor. P80C321. Intel 9080, so pretty old school. We got a supercapacitor, rated for 5.5 volts, 0.74 farads. And there's some other chips here, memory chips, socket head. There's some op amps, LM324AN, it's an op amp. And some more stuff. And lots of passive components, so caps and resistors. And some potentiometers on top. Not so much on the back. That looks nice. That's awesome. Look at that. Look at all of those sensors. It's a LED on one side and the transistor on the other. So light passes through. Something got in between, it switches. And that was actually going on this thing here. So if you have some special hoses, when you connect to them, it will detect which type of hose you have connected to it. So that's nice. There's little tubes that was going into that. Into this stuff here. And here's those fiber optics. We bring this near the light here. You can see some lights in it, and I put a finger on it. And that's how they work. That's the fiber optics, some wiring. Was all of that connected in parallel? All of those? Yes, that was nice. That I didn't know that. All of that is connected in parallel. You see, all the red ones are connected together, and all the black ones are connected together. So all of that would switched at once. And the display board, what do we got on that? Some display drivers. Some 74 series chips. That's only one. Now you got two. That's another one. That's another one on top. Another one here. So maybe you can see what that is. There's bad lighting in here. Yes, 74 series chips. All of these are socketed. Look at that. How nice is that? That's pure porn. They have socketed all of the LED displays. All of them are socketed. Isn't that awesome? There's a little buzzer on the back. I think they've done that. Look at those! Those are socketed as well. Look at that. I've never seen something like this. Why didn't they just connect all of those displays on the back and have it the other way, if those chips are a bit too high? Or was that the front was so thick? Look at that thick plastic. That's maybe why they needed to socket all of those panels. Easier way would be just to put them on the other side and solder them on that side instead. And have these chips on the back. That way this one would be the back side and the displays would be come on the back side and that would be the front. That would be easier. Now they have socketed all of them. So now I don't need to desolder them. I can just pull them out like that. That's awesome. I've never seen something like this. All of those are socketed. That's high quality stuff. In the beginning, this would not be cheap. This looks extremely expensive. All those arrayed sensors here and stuff. Chips from 1980. I think this would be cost a lot when it was new on that time. So before I end this video, I'm going to show you some really nice stuff. Of course, it's made in the United States of America, as you can see here. And one thing is all of those test points. So I'm just gonna show you them. You can hold this right. So as we got 2 test points here, test point 1 and 2. And there's not so much test points on the bottom side here, because they knew that you can't get to this part easily when it's in the case. So what they've done, they've put all the test points on the top here. Look at that. There's all the potentiometers to test point 7, 4, 12, 11, all of them here. But then we need to be more test points. Where are the rest? We don't got anything on the back because they know that there's not easily reached. But we don't got so much else test points. It begins with 4 here, it ends with 2 up here. So we're missing some test points. Where can they be? Yes, I couldn't find the test point 3, but I found the test point 5, which is in between here. And there are lots of test points on this display board as well. Got some test points up here. And of course, nothing on the back. No test points on here. Which is a bit bad, because you can't see the front side of this. They should have put some test points on here instead. That would be much better. So, yes, up there with all the test points. And 1990 copyright. And the power supply. Same thing here, not so much test points here. We got one here. And a bond. Don't know what that means. A bonded those two together. And we got some test points here. Lots of test points. And of course this time we got a lot of test points on the back. So easily reached. And very good serviceable stuff. So you can easily probe those and see if the waveform or the voltage or anything is right on them. So I think that's all about it. Thanks for watching.